let's do our very quick review on multiplying fractions. Okay, so if we have 3/8 times, I don't know, let's say 3/4. Okay, multiplying fractions is very simple, right? Multiplying fractions is 3 times 3 is 9, and 8 times 4 is 32, so 9/32. So for multiplying fractions, we multiply the numerators and we multiply the denominators, and it will give us our answer. Okay, very, very simple. And remember, if we get fractions like let's say 3/4 times 2/3 times, I don't know, let's say 3/16. You know, what happens when we get multiple fractions that we want to multiply across? It's exactly the same. But remember, any time that we get an answer when it comes to a fraction, we want to reduce it to its lowest terms, right? So this happens to be in its lowest terms, 9/32. But let's work this problem through two ways. So I'm going to write it twice. 3/4 times 2/3 times 3/16. Okay, so I'll multiply across the top. 3 times 2 times 3, 18. And then 4 times 3 times 16, multiply across the bottom, is 192. So now we have to reduce this into lowest terms, right? So right away we look at this, maybe think, I have no idea, you know, what evenly divides into both. So a lot of times we start with something we know, right? So we could divide them both in half and see what we get, right? So 18 divided by 2 is 9, and 192 divided by 2 is 96. Now, if we don't know if it'll divide any lower, we can try different things, right? It's a trial and error thing, right? So we could try 96 divided by 3. It works out, right? 96 divided by 3 is 32. So we'll move this down here, okay? So there's 32 3s in 96, so we'll put 32. How many 3s in 9? 3. So this is what it reduces to, 3/32. So we had to kind of multiply the numerators, multiply the denominators, get our fraction, and then reduce it, and then reduce it again, and now we're at our lowest terms. But since we have to reduce anyway, okay, we can simplify our problem down here. So remember, what we can do is we can take a numerator in one fraction and a denominator in another, and if there's a number that they're both divisible by, we can use it. For instance, this 3 and this 3, right? How many 3s in 3? 1. So I can cancel this and cancel this, right? There's 1 3 in 1 and 1 3 in 1. So let's take this and make it clear, right? We're trying to reduce our fractions. So this was a 3 and this was a 3. Okay, I can reduce these fractions by getting rid of this 3 and making it a 1, right? Because there's 3 1s in 3. So the same here, 3 1s in 3, right? How many 2s in 2? 1. How many 2s in 4? 2. So remember, you have to do a numerator and an opposite denominator in one of the other fractions. Is any more of this? Can we reduce any more of this? Right? Well, no. We're at our lowest right now, right? There's no numerator and opposite denominator that are equally divisible by a number. So 1 times 1 is 1 times 3 is 3. 2 times 1 is 2. 2 times 16 is 32. Okay, so notice, same answer, right? So we can multiply across and then reduce, or we can simplify the fractions before we multiply across. So the way to do that is to find numerators and denominators, and we could have used the 2 and the 16 too, right? how many 2's in itself? 1. How many 2's in 16? 8. Right? So it would have been 4 times 1. Or we could have done, oh, and then we could have reduced it again, right? So another way we could have done this, we could have turned this into a 1, this into an 8. Yeah, we can only do it once. And then we can take this 3 and this 3 if we want and make it 1 and 1, right? So 3 times 1 times 1 is 3. 4 times 1 is 4 times 8 is 32. Okay, so as long as it's an opposite numerator and denominator.